In lesson 5.2, we're going to start to learn how to describe numerical variables with summary statistics. Some of these summary statistics we're going to discuss are ones that we learned about earlier in the course, so we'll review those and then talk about a new one. And as we move throughout this chapter, you'll learn about some other types of summary statistics. Now, besides describing the shape of the distribution like we did in lesson 5.1, it's also useful to describe the center and the variability in a data set. So with the shape, we're talking about things like symmetric or skewed left or skewed right. And so far, when we've talked about the center and the variability, we've just sort of eyeballed it and said the centers are about the same or the center is about at this value. And when we talked about variability, we've just sort of looked at how close together the data is without really being able to quantify that with a number. And that's what we're really going to start to do in this section. Now, you may remember that when we're discussing the measures of center in a data set, there are two values that we can use, and those are the mean and the median. The mean is the average. So if we add together all of our data and divide by the number of data points we have in our set, that will give us the mean. And then the median is the middle number if you put your data in order from smallest to largest. So we're going to review both of those. Here we have an example that's showing us the number of points the West Ottawa High School boys football team scored in each of their games during the 2017 season. And during that season, they finished 10-2, including 2 playoff games. So we have the number of points scored there. And I also gave you a histogram showing the relative frequencies. So we can see, for example, that in about 17 or 16% of their games, they scored between 20 and 25 points. The tallest one was there between 30 and 35, and so on. So, first of all, what shape does this distribution have? Even though it's not perfect, we would say that this is roughly symmetric. Now we can calculate the mean. So if I add together all the points from that list there at the top and I divide by 12 because they had 12 games, we get a mean of 33.08. Now let's do the median. And so for the median, we have to take all of those different scores and we need to put them in order from smallest to largest. So I did that there across the top of that example. Now we have 12 games total. So if we want to find the middle, and with an even number of games, we would split that into two groups of 6. So we have 6 and 6. The median then would be exactly halfway in between these two scores that are closest to the middle. So halfway between 33 and 34 would give us a median score of 33.5. Now, if they had an odd number of games, you could very easily find the middle score. But remember, with an even number, you want to go halfway between the two that are closest to the middle. Now, in D, it asks us to compare the mean and the median. Now, the mean is 33.08 and the median is 33.5. Those are very close to each other. So we'll say that they are about the same. And the reason that happened is because our distribution was roughly symmetric. So when you have a distribution that is roughly symmetric, your mean and your median should be very close to each other. Maybe not exact, but they should be pretty close. All right, let's try the same thing for Holland High from that same season. And during that season, they finished 6-4, and we have the number of points that they scored in each of their games there. I would recommend that you pause the video and try the mean and the median calculations and see if you remember how to do those. So for part A, it's asking us what shape the distribution has. We would say that this distribution is probably skewed to the right. Most of their games, they had a pretty low score. They had quite a few games that were 12, 14, 16 points. And they did have a couple that were on this high end over here, but most of them are over here. So we kind of have a tail going out to the right. Now, for the mean of that distribution, I got 25.8 points. And for the median, I only got 19. So now when we compare the mean and the median, what happens here is that our mean is greater than the median, right? They're not really that close. They're off by almost 7 points, which is like a full touchdown in football. Now, the reason that the mean and the median here are not really that close to each other is because of the shape of our distribution. And because Holland had these two games over here where they scored lots of points, and we sort of have this skewed shape, these games over here are pulling the average up. So when you have a skewed distribution, the mean is always going to get pulled toward the tail of the graph. So it's not going to be approximately where the median is. And that's why knowing the shape of a distribution is important because it gives us some information about how the mean and the median are related to each other. So if you have a distribution that is symmetric, your mean and your median will be approximately the same. If your distribution is skewed to the right, which means you have a tail going to the right, then our mean is also going to be pulled to the right. The median is going to stay where most of the data is located, but the mean will be pulled toward the tail. So the mean in that case will be greater than the median. And if the distribution is skewed to the left, then that means we have a tail on the left-hand side and most of the data is to the right. So the median will stay where the data is, but the mean will be pulled to the left. So in that case, our mean will be less than our median. Now, besides knowing the center of a data set, it's also useful to describe the variability in a data set. And so far, we've talked a little bit about range and how the range of a data set is the difference between the max and the min. We're also going to use what's called the interquartile range. And the interquartile range we define as Q3 minus Q1. Q3 is the third quartile and Q1 is the first quartile. And we'll show you how to find these in just a moment. And we're going to do these by hand in this lesson. And then in the next lesson, we'll show you some calculator shortcuts for finding these values. So here we have West Ottawa's football data again, and I have it sorted for you from smallest to largest. We're going to use the data to find the range and the interquartile range. So first, let's start by finding quartiles and talking about what those are. When we do the median, remember we split the data into two equal halves. So just like we did in that first example, I took my 12 football scores and I split them into two groups of 6. So in that case, remember we know that the median is halfway in between there, so that would be 33.5, and we know that already from example number 1. Now I have two halves of my data, and I can now take each half and split it again in half. So when you do half of a half, you're finding a quarter, and that's basically what a quartile is. So for the bottom 6 scores, the midpoint or the middle would be in between the third and the fourth score. So I'm taking that group of 6 and now I'm splitting it into two groups of 3. So halfway between 27 and 28 would be Q1 or the first quartile, and that would be 27.5. Now, if I repeat that with the upper half of my data, again, I've got 6 scores up there, and I want to go halfway in between 35 and 41, and that would give me the third quartile or Q3, and that would be 38. So now I can find my range because my range is my high score minus my low score. So 48 minus 20, that would give me a range of 28 points. The interquartile range, which we abbreviate IQR, is Q3 minus Q1, and that gives me an IQR of 10.5. All right, I would recommend now that you pause the video and try to find the range and the interquartile range for Holland High's football scores from that season. Notice they're already sorted for you from smallest to largest. All right, for Holland High, Q1 would be 14. That's the middle value of that bottom half. Here we have 5 scores, and so the middle value is right here. That's the middle number. In the upper half of the data, our middle number right here is 36. So that would be Q3. The range would be 58 minus 6, which is 52 points. The IQR is 36 minus 14, which would be 22 points. Now the question is asking you to compare which team scores, West Ottawa or Holland High, have more variability. Well, Holland High has a much larger range. They also have a bigger IQR. So we would say that Holland High, therefore, has more variability in their scores. Please do homework 5.2 in your assignment packet.